Okay, so John's an extension educator. He's focused on energy, renewable energy, and biofuels. He's taught here at UNL since 2004, and he's done a number of extension-related projects and things like that in that time frame as well. So I'm going to go ahead and turn it over to him, and he can explain better about what he does. But he's a solar panel guy. I do know that. He does a lot with solar panels. So I'll turn it over to John. Thanks.
That was a fine introduction of me. You don't need to know anything else about me because the next two speakers don't have a lot of time to get across what they're trying to say, so I'm going to try to keep my introduction short. But we have two speakers coming up next. One is Stonie Cooper, and his name's up on the board here, and he's the the manager of the Nebraska Mesonet network, and that is a fancy way of saying weather monitoring stations, but I might argue that they're probably fancy weather monitoring stations. And he hails from western Nebraska and spent some time in private industry with the Weather Channel and his own private business prior to coming to Nebraska. I'm going to go ahead and introduce our second speaker right now, so I don't have to do it again in a minute. But our second speaker is Aaron Young. He is with the Conservation Survey Division here at UNL and works with monitoring of groundwater levels, and is going to talk a little bit about the history and the current status of groundwater level monitoring here in Nebraska. So I'll turn it over to Stonie.
Can you hear me okay? So I like jokes a lot. So what did one raindrop say to the other raindrop? 2 is company, 3 is a cloud. So I manage the Nebraska Mesonet. Funny story about Mesonet is that if you look at it and you're not familiar with mesoscale or networks or anything, it might appear to you to be Mesonet. That was an IT person who said, hey, I want to talk to you about your Mesonet. Mesonet is a mashup of 2 words, mesoscale, which is a geographical area definition, and network is what we obviously know. And so a Mesonet is a network of automated weather stations and environmental monitoring stations designed to observe mesoscale meteorological phenomena. And by extension, when you save that meteorological data, you create a climate database. The most notable first use was by Dr. Ted Fujita in the early 1960s when he was talking about the ability to predict tornadoes was going to rely on a much denser observational network that then existed at the time. The Nebraska Mesonet started in 1981 with 5 stations. You had the one at Meade, and then you had 4 out in southwest Nebraska. This was a grant-initiated process. And this is what it looks like today. We have 68 operational stations plus a research station out at Rogers Farm. This is a picture of one of our stations. I'm going to go pretty quick because what Aaron has to talk about is very interesting when it comes to the water tables and groundwater status right now. So this is Grant 1 East. This is what a typical 3-meter weather station looks like. And I'm going to break it down so you know exactly what parameters that we're measuring. Under vegetation, we have 5 soil depths that we measure temperature and moisture on an hourly basis at 5, 10, 20, 50, and 100 centimeters. We also, under bare soil box, at 10 centimeters, we measure temperature. This is on a 1-minute basis. Over here, see our 1 meter warm season liquid precipitation. It's a tipping bucket. At 1.5 meters, right here inside the NEMA box itself is a station pressure barometer. And at 2 meters, we have temperature and humidity, which is the gill-shielded thermistor. At 2.5 meters, we have the incoming shortwave radiation. For those who are big into looking at energy budgets, it measures between 400 nanometers and 1100. And then we have the 3-meter wind speed and direction. And that's how a typical station is constructed. We do have a few variants throughout the state, but this is our standard. If you want to go look at our products and look at the data itself, you can go to our website. The homepage actually has all the stations plotted on a map. If you click on those, you'll get 3 pictures and you'll get a full description of where the station is located, what its name is, and who is paying for that station to be in place. If you go to the real-time weather maps, you can see the current data. Nebraska, unfortunately, is broken up into 2 time zones. So we make sure that we display both time zones up there, but we have a drop-down menu that's up here. You bring that down, you can see temperature, relative humidity, dew points, cattle comfort index. Rick? Wind chill, and other dry parameters. We also work and collaborate with CropWatch, and so that there's daily, weekly, monthly, and previous month precip maps that are put out, as well as weekly average soil temperature under the bare soil boxes. Our current upgrades that are underway is we're increasing the data capture from 5 minutes to 1 minute. We have roughly 12 stations done. We're also, when we're doing that, increasing the collection time from 20 minutes to every minute. So we're basically getting real-time data from these stations. And again, we have roughly 10 of those converted over. And we're also starting this summer with adding redundancy for every sensor that's above ground. This summer we're starting with tipping buckets, and we're going, because that is our most used product, is precipitation. And then from there we're going to add redundancy. And not only are we adding redundancy with a particular parameter, but we're using a different manufacturer and model of that, so we have a better redundancy in the sense that you're not relying on the same exact instrument. Future goals is we want to increase the network density to better represent the entire state. When asked to articulate this better, we would like to have at least 1 station per county in the state of Nebraska. We have 68 operational stations. We have 93 counties, and some of those counties have multiple stations. As you notice, Lancaster County is way overrepresented if you want to look at it from a scientific point of view. We also want to move from the 3-meter tripods to the 10-meter towers, of which we have now, we're up to 3 that we've converted over. And then we also want to improve our data delivery and representation of that data. And that is ongoing right now with a new website redesign and way that data can be delivered to people. And this is my info. I said I'd make it short to give you plenty of time. We're going to have all the questions for both of us at the end.
Okay, so once again, I'm Aaron Young. I'm a geologist with the Nebraska Geological Survey. It's also known as the Conservation Survey Division at the University of Nebraska. Try and keep that to a minimum.
Well, it doesn't have an off button. Smarter than the mic, I guess. Try again.
Okay, I'll try and stay away from it. So what I'm hoping you're going to take away from this talk today is the answer to 2 questions. So how much groundwater does Nebraska have, and what is the status of our groundwater? To get right into it, how much water do we have? In short, Nebraska has a lot of groundwater. However, although our groundwater resources are vast, they're not infinite. This is a hard lesson that some of our neighbors to the south have been learning here over the last decade or so. To put some numbers on this, and mostly I'm going to talk about the High Plains Aquifer here. So the High Plains Aquifer covers most of Nebraska. It's just a little sliver on the eastern portion of the state that it doesn't cover. This is where the vast majority of our groundwater comes from. The High Plains Aquifer in total covers parts of 8 states. In total, that's about 175,000 square miles. Our portion of it in Nebraska covers right around 65,000 square miles. So that's about 36% of the aquifer in total. In that 36% by area of the High Plains Aquifer, we have nearly 70% of the total volume. So to put some numbers on that, that comes out to 2.04 billion acre feet of water. So that's a huge number. If you want that in gallons, that's this mind-bogglingly large number up here in the top. So to put that in a little bit of context, the Platte River, where it flows into the Missouri River, flows at about 8,000 cubic feet per second. At that rate, that's 326 years of flow of the Platte River. So I come from Wisconsin. I grew up on the border, on the Great Lakes. To put that in a little bit different context, that's more than the volume of Lake Erie and Lake Ontario combined. So that's those two. It's almost as much as the volume of Lake Michigan. The thickest part of our aquifer, or of the High Plains Aquifer, falls in the southwest corner of Cherry County. If we just look at Cherry County has 287 million acre feet of water. That's just in that county alone. So that's 17 million acre feet more than is available in the High Plains Aquifer in Kansas. That's almost as much as what's available in the High Plains Aquifer in Texas. So there's some pretty impressive numbers. Now, both those states have other aquifers that supply water to the rest of the state. So that's not their only water supply, but that still puts our water in a pretty good context. So that's the answer to the first question. And really, this is a question that could be answered over the course of a semester-long college class. If you have some questions on either of anything I'm presenting here, feel free to give me a call. My contact info is at the end here. So that brings us up to our next question, and that is, what is the current status of Nebraska's groundwater levels? So to answer that question, back in the late 1920s, Nebraska began to realize that our groundwater resources really are vast, and they are very important to how we do things in Nebraska. So the Nebraska Groundwater Level Monitoring Program began back in 1930. It's a collaboration currently between 30 different state and federal agencies. Most of our observation wells are measured by the Nebraska Natural Resource Districts. They supply us with a great deal of that information, in addition to wells that are measured by the U.S. Bureau of Reclamation, University of Nebraska, and the USGS, and a couple public power and irrigation districts. Currently, we're reading right around 5,400 wells annually. 60 of those have CSD installed hourly real-time monitoring equipment. So just in the way you can go to the State Climate Office website and get up to the minute or up to the hour climate data, you can go to the CSD data's website and get up to the minute, or up to the hour, I should say, groundwater level information. So I just like to throw this slide in here. This is a very time-consuming and costly program to run. Why are we doing this? Well, Nebraska has 8.3 million irrigated acres. We lead the nation in irrigated acres. We surpass California, which has 7.5 million. On those 8.3 million acres, we're applying 8.1 million acre feet of water, from which 7.4 million acre feet is coming from groundwater. We have more than 96,000 irrigation wells in the state. So the prosperity of Nebraska's almost 16,000 farms and our economy depends very heavily on that groundwater we're pumping. So it's very important for us to monitor and conserve this water for future generations. So not all of this water is being pumped evenly statewide. Obviously, the density of irrigation wells is going to vary across the state as to where it's most suited to grow crops. Most of that is going to be in the eastern half of the state. We also do have some fairly high areas of densities of irrigation wells in the Panhandle along the North Platte River in Box Butte County, and also in the southwest part of the state. So these are the areas where we're going to see most of those groundwater level changes. Once again, our observation well network, we've got, on this map, there's approximately 6,000 wells that go into making our maps. Once again, most of these wells are measured by our data cooperators. We at the university take that information and we combine it, and we create maps and reports to show the status of groundwater levels in our aquifers. We do that on a number of different time scales. The first map that comes up, usually the map that gets the most press, that most people want to look at, is the 1-year groundwater level change map. In my opinion, this map isn't really telling us a whole lot. It's not really showing us trends. A lot of what we're seeing here is timing. A lot of the NRDs have regulations on you can pump so much water over multiple years. A lot of these little changes, these little dots are individual irrigators changing their irrigation plans. It's when we start getting into the longer time series that things become a little bit more important. This is 2013 to 2018. So this is a rather important map for Nebraska, and we'll come back to this. 2013 was one of the hottest and driest years on record. So this is something that's been talked about a number of times today. Obviously, precipitation was down in 2013. This had a pretty severe impact on groundwater levels. This is actually one case where that 1-year map becomes a little bit more important. Between the spring of 2012 and the spring of 2013, the average groundwater level decline in wells in Nebraska was a little less than 3 feet. So in that eastern half of Nebraska, we saw groundwater level declines up to 25 feet. Since then, those water levels have been coming back up. So these aren't permanent declines. Most of what we've been seeing near average to above average precipitation during this time, and that's been a big help. For most of eastern Nebraska, most of those groundwater levels have returned to close to pre-drought levels. It's really just some of the areas to the south of the Platte River that are still recovering. This is something that we can pick up on our 10-year map. This is where we start to see some of those trends start to pick up. So areas in the Nebraska sandhills, areas that don't get pumped very heavily for irrigation, many of those wells have been coming up for the last several decades. Areas in western Nebraska and the southwest part of the state, in the Nebraska Panhandle, where we're pumping groundwater that is relatively deep, it's hard to replace. They don't get a whole lot of precipitation to recharge those aquifers. We're seeing declines that average about a foot a year. In my opinion, at least, this is one of the most important wells or important maps that we produce. So Nebraska, once again, realized very early on that it's important to be able to monitor our groundwater levels. What this map is showing is changes in groundwater from before human influence was seen in wells. So that date varies in different parts of the state between the 1930s and the 1960s. This is how much groundwater levels have changed since that time. We see a number of patterns here. So in the western part of the state, the most severe declines that we see are right around 120 feet. And those are in parts of Chase, Perkins, and Dundee counties and parts of Box Butte counties. Some of the other declines we see, particularly in the southeast part of the state, those declines have been up to 30 feet. Over the past 40 or so years, some of those declines have stabilized. Many of those areas are starting to come back up, and that's due to a variety of reasons. Some of the other trends that we've seen in central Nebraska around the Calamus River and just to the south of the Platte River, south of Buffalo County, we've seen rises of relatively equal magnitude. So we've seen groundwaters actually come up through time by almost 120 feet. And that's really the result of many of the old irrigation channels that were put in those areas. The flood irrigated fields, all those things were unlined. All that water is seeping back into the aquifer. So with that, I guess the point that I'm trying to have as a takeaway here, a lot of times you hear when it comes to groundwater, a lot of doom and gloom stories. In Nebraska, that's not necessarily the case. We've been monitoring and conserving our groundwater for almost a century now, and really as far as groundwater conservation programs go, we really lead the country in many ways in the ways we do this. So with that continued support in place, we should have groundwater going well into the future. For some useful resources, this is our real-time groundwater level monitoring page. You can go to the site, you can get access to all our data sets. And with that, I think we can take some questions.
Do we have any questions for Stonie or Aaron? We have some over here and one back here. Stonie, do you want to stand up?
Question for Aaron. I was reading an article in New Mexico where the military inadvertently, we'll say, contaminated the aquifer down there, which should be the lower end of the High Plains Aquifer, and it's now absolutely destroyed their agricultural system because everything is contaminated, all their farmland, all their animals that they're having to put down. Are we at risk because it's the same aquifer system and it's been contaminated so heavily within the same groundwater?
Okay, so I'm going to start and say that I'm not a groundwater quality expert, but I can say this. So are we at risk of having our water in Nebraska contaminated by what's going on in New Mexico? And the answer to that is definitely not. So the water just does not move that way. So if you look at Nebraska, the easiest answer is Nebraska is sloped, so water is going to flow downhill. Western Nebraska is much higher than eastern Nebraska. Our general movement of water is from west to east. Even if water could move in that north to south way, the High Plains Aquifer is almost cut through at basically the southern Nebraska border. So even if it was possible for water to move in that direction, it would not move past essentially the Republican River. So, you know, these contamination issues do come up, but what happens in other parts of the aquifer, water just does not move that way. Does that answer your question? Yep.
So question for Aaron then, what are the contributing factors for the Chase, Perkins, Dundee County area with the severe change that they've had?
So what's happening there is, you know, that area of the state doesn't receive a whole lot of precipitation. Stonie, that's maybe 14 inches?
14, 15.
14, 15 inches. So we're pumping relatively deep, relatively difficult groundwater to replace to grow crops in that area. And essentially we're not able to replenish what we're taking out. So we're pumping it faster than it's going back in.
John pointed back in this direction. I feel like I'm like the guy that lines up punts in a football game. I hit it.
Thanks. Well, I think it seems like everybody's got questions about water, but I was wondering if the areas in Box Butte County and southwest Nebraska, are they in danger of running out of water, or just is it a matter of drilling deeper wells? And if so, what kind of timeline are they looking at in terms of of water depletion?
So that's a difficult question to answer. If you look at the hydrographs for these areas, groundwater levels are declining fairly linearly at about a foot per year. So at least in parts of southwest Nebraska, we've got roughly 300 feet of saturated thickness. You would think that you'd be able to plot that line up and say, we've got 300 years of water left. And unfortunately, the way that the aquifers work, that calculation just doesn't work. Making forecasts like that are a rather difficult thing to do. I can't really say that we're going to run out of water at this date. Our chances of actually running out of water in those areas are, at least in the foreseeable future, pretty low. I'm not saying that we should pump unrestricted and just take as much as we can use, but it's something that we need to keep monitoring and make sure that we're not using these aquifers beyond their limits. We have those regulations in place, and unfortunately, I don't have a real good answer to your question there. Making those kinds of calculations is really kind of difficult to do. I know some of the work that's going on in those areas is to model how the aquifer is going to respond to continued pumping. And when some of those models are complete, we'll have a little bit better answer on that. But I would say that, in the foreseeable future, we're not in any real danger of completely depleting those areas.
Got one more question here, John. Is that cool?
Aaron, I'm just curious about the woody encroachment in Nebraska, particularly the red cedar, and wondering if you're concerned about that with the impact on infiltration, or are you monitoring that or modeling that in any way?
Honestly, we're not. That's something that I know what you're talking about, but I really don't have a background on that to give you an answer. I'm sorry.
All right. Let's thank Stonie and Aaron.